So far we have seen the how the rainbow is formed. So rainbow formation of rainbow is due to the dispersion as well as the refraction, I said. So here we will look at the other natural phenomena of sunlight, that is scattering of light. So here whenever a light passes through the atmosphere consists of the molecules of various sizes. So whenever the light passes through these molecules absorb the light and then emit the radiations in all possible directions, and that phenomenon is called as the scattering. See here, if the molecules after absorbing all the radiations emit in all possible directions, that phenomenon is called as the scattering. That means emission of the light after absorption from the sunlight is called as scattering. Scattering is nothing but emission of the radiations falling on them by the molecules. See here, if at all the wavelengths, whatever the wavelength absorbed, because light is coming to the molecules and it has got certain wavelength, and whatever the wavelengths absorbed by them are equally emitted back, then you call it as the elastic scattering. That means if the wavelength remains unchanged during this scattering, then you call it as the elastic scattering. Now here, according to the Rayleigh criteria, a scientist called Rayleigh, according to him, so it totally depends upon the intensity of the scattering light, totally depends upon the wavelength. That means intensity of scattered light is inversely proportional to the lambda power 4. That means amount of the scattered light depends upon the nature of the molecules as well as the wavelength of the light. So here it is to be observed, blue light is scattered much more than the red light. That is the reason whenever the light passes through the atmosphere, most of the light scattered is blue. That's the reason the sky appears blue, because blue light is scattered more. So that is a point here to be noted. Blue light is scattered much more than the red light. And here you can also have one more explanation for the why the sun appears red during the sunset or before the sunrise, why the sun appears red. So if you look into that, in the noon, during the midday it appears whitish, whereas when it comes to the sunset time it appears to be reddish. The reason is, when the sun is at the horizon, the light coming out of the sun has to travel through the atmosphere for the longer distances. So when the light travels through the atmospheric particles, most of the light that's scattered is blue. Therefore, blue color is scattered away. Only the remaining will be reaching to the human eye standing at the distant point. That is the reason the leftover light is only the red color. Hence, it appears to be red. That means when sun is farther distance, the remaining colors are scattered off. Only the red color whose wavelength is high, the higher wavelength light will be reaching to the person. And that you can observe in the figure which I have given in this. And now one more point you need to remember, why the traffic signals, the danger light is red in color, means because it can be reached to the longer distances without any scattering. That means at longer distances also it can be seen clearly. That is how the traffic signals or danger signals are always in red color. That is one more point you need to remember here. So scattering of light, as a conclusively you can say, scattering of light is due to the absorption of radiations by the atmospheric molecules and emit the same. So the radiations that are emitted by the atmospheric particles after absorbing the sunlight is called as the scattering. So here 2 points you need to remember: the reddishness of the sun as well as the sky appears blue. That is because of the scattering nature of the light, and this is one of the applications of the natural phenomena of light. So rainbow is one application and scattering of light is the other application, and now we look at the other cases also.